Hello guys, what's up? This is Sir EJ and welcome again to another math tutorial. In today's topic, we will be discussing how to sketch the graph of a polynomial function. So let's have our objectives in today's lesson. At the end of the lesson, the students should be able to, letter A, find the x and y intercept of a polynomial function. Letter B, sketch the graph of a polynomial function. And letter C, describe the graph of a polynomial function. So the first thing we need to do to sketch the graph of a polynomial function is to solve for the x and y intercepts. Solving for the x and y intercepts is an important step in graphing a polynomial function. These intercepts are used to determine the points where the graph intersects or touches the x-axis and the y-axis. So to find the x-intercept of a polynomial function, the first thing we need to do is to factor the polynomial completely. And then after that, let y be equal to 0. And the last step is to equate each factor to 0 and solve for x. And then to find the y-intercept, we will let x be equal to 0 and then simplify. So the next step is to find the end behavior of the graph. So the end behavior will help us determine the appearance of the graph. So let's have condition number 1. If the value of the leading coefficient of the leading term is greater than 0 and the value of the exponent is an odd number, then the end behavior is located at quadrant 1 and quadrant 3. Next, let's have the second condition. So in condition number 2, if the value of the leading coefficient of the leading term of the polynomial is greater than 0 and then the exponent is an even number, then the end behavior is located at quadrant 1 and quadrant 2. Then let's have condition number 3. If the value of the leading coefficient of the leading term of the polynomial is less than 0 and then the exponent is an odd number, then the end behavior is located at quadrant 2 and quadrant 4. Next, let's have the last condition. If the value of the leading coefficient of the leading term of the polynomial is less than 0 and the value of the exponent is an even number, then the end behavior is located at quadrant 3 and quadrant 4. So the next step is to find the number of turning points. So in finding the number of turning points, we have the number of turning points is at most n minus 1. So meaning to say, we will just subtract the highest degree of polynomial by 1 to get the number of turning points. And then after that, we will identify the multiplicity of roots. If r is a zero of odd multiplicity, the graph of p of x crosses the x-axis at r. And then, if r is a zero of even multiplicity, the graph of p of x is tangent to the x-axis at r. So let's have an example. Sketch the graph of y is equal to x to the 4th power minus 5x squared plus 4. So we need to solve for the x-intercepts. And to solve for the x-intercept, we will apply the rational root theorem. So we will get the possible roots of the polynomial equation. So we have positive negative 1, positive negative 2, and positive negative 4 as the possible rational roots. Then we will test it using synthetic division. So let's try using positive 1. We will write positive 1 here, and we will get the numerical coefficient of each term of the polynomial function. So the numerical coefficient of x to the fourth power is 1. The numerical coefficient of the cubic term is equal to 0 because it is missing in the equation. So it will be equal to 0. The numerical coefficient of negative 5x squared is equal to negative 5. And the numerical coefficient of our linear term, which is missing, is equal to 0. And then the numerical coefficient of the constant term is equal to 4. And then we will draw a line here. So bring down 1. 1 times 1 is 1. 0 plus 1 is 1. And then 1 times 1 is 1. And then negative 5 plus 1 is negative 4. 1 times negative 4 is equal to negative 4. And then 0 plus negative 4 is negative 4. And then 1 times negative 4 is negative 4. And then 4 plus negative 4 is equal to 0. So if the value of the remainder is equal to 0, then 1 is one of the x-intercept of the polynomial function. So our first coordinate is 1, 0. And then let's try to use x is equal to negative 1. So write negative 1 here. Get the numerical coefficient of the quotient. So we have 1, 1, negative 4, and negative 4. Then use synthetic division. Draw a line here. Bring down 1. Negative 1 times 1 is negative 1. 1 minus 1 is equal to 0. And then 0 times negative 1 is 0. Negative 4 plus 0 is negative 4. And then negative 1 times negative 4 is equal to positive 4. And then negative 4 plus 4 will be equal to 0. So if the value of the remainder is equal to 0, then negative 1 is one of the x-intercept of the polynomial function. So the second coordinate is equal to negative 1, 0. So by the way, in this polynomial function, we will have 4 x-intercepts because the highest degree of polynomial is equal to 4. So therefore, there are 4 roots or 4 x-intercepts. So let's now continue. So we will get the depressed form of the quotient of the polynomial function. So the equation will be x squared minus 4 equals 0. And then after that, we will factor x squared minus 4 equals 0. This is sum and difference of 2 squared. So we have x minus 2 times the quantity of x plus 2 equals 0. We will equate x minus 2 equals 0, and then we will solve for the value of x. So we will transpose negative 2, so the value of x will be equal to 2. So the third x-intercept will be x is equal to 2, and then the ordered pair is 2, 0. And then again, we will equate x plus 2 equals 0. So we will transpose positive 2, it will become negative 2. So the value of our last x-intercept is equal to negative 2. And our last ordered pair is equal to negative 2, 0. So the x-intercepts are 1, 0, negative 1, 0, 2, 0, and negative 2, 0. So after we have compute for the value of x-intercepts, so we will now solve for the value of the y-intercepts. So to solve for the value of y-intercepts, we will just substitute 0 to the value of x. So we have y is equal to 0 to the fourth power minus 5 times 0 to the second power plus 4. So y is equal to 0 to the fourth power is 0. Negative 5 times 0 to the second power is 0. Plus 4. So we have 0 plus 0 plus 4 is equal to 4. So y is equal to 4. So our y-intercept is equal to 4. And our coordinates is equal to 0, 4. So after we have solved for the value of x and y-intercept, we will write the equation y is equal to x to the fourth power minus 5x squared plus 4 in factored form. So these are the x-intercepts. We have 0.10, negative 10, 20, and negative 20. So to get the factored form of the equation, we will just change the sign of the x value of our x-intercept. So the factored form will be y is equal to x minus 1, positive becomes negative, times the quantity of x plus 1, negative becomes positive, times the quantity of x minus 2, positive becomes negative, times the quantity of x plus 2, negative becomes positive. So this is the factored form of the polynomial function. And then after that, we will get the end behavior of the polynomial function. So we will get the leading term of the polynomial function, which is x to the fourth power. And then after that, we will identify its leading coefficient, which is equal to 1. So 1 is greater than 0. And then after that, we will look at its exponent or degree of polynomial, which is 4. And 4 is an even number. So if 4 is an even number, then the end behavior is at quadrant 1 and quadrant 2. And then after that, we will get the number of turning points. To get the number of turning points, we will just get the highest exponent, which is equal to 4. Then we will subtract it by 1. So 4 minus 1 is equal to 3. So the number of turning points is equal to 3. And then after that, we will get the multiplicity of roots. So to get the multiplicity of roots, we will look at the factored form of the polynomial function. So x minus 1, the exponent of x minus 1 is to the first power. Therefore, it has an odd multiplicity. The exponent of x plus 1 is 1, and 1 is an odd number. Therefore, it has an odd multiplicity. Same goes with x minus 2 and x plus 2. They have an exponent of 1, which is an odd number. Therefore, it has an odd multiplicity. The graph will cross the x-axis if it has an odd multiplicity. So the next step is to construct a table of values. So let's place the x and y intercepts on our table of values. So we have 0.10, 0.-10, 0.20, and 0.-20 as our x-intercepts. And we have 0.04 as our y-intercept. Now to fill up our table of values, so we will look at our abscissa. So the abscissa is our x values. So we have 1, -1, 2, -2, and then 0. So we will think of x value that we can add on our table of values. And those x values that we will think must be somewhere in between or the next term of these numbers. So let's try using x is equal to 3. So we will substitute 3 with our polynomial function y is equal to x to the fourth power minus 5x squared plus 4. Substituting it, we have y is equal to 3 raised to the fourth power minus 5 times the quantity of 3 to the second power plus 4. And then after that, we will simplify. Y is equal to 3 to the fourth power is 81. And then 3 times 3 will be equal to 9. 9 times -5 is -45 plus 4. And then y is equal to 81 minus 45 plus 4. Then the value of y is equal to 40. So if x is equal to 3, then y is equal to 40. So we have 0.340. And then after that, let's have x is equal to -3 because the number besides -2 is -3. So let's try to substitute -3. So we have y is equal to -3 to the fourth power minus 5 times -3 to the second power plus 4. So we will simplify. -3 to the fourth power is 81. -3 times -3 is 9 times -5 is -45. Bring down 4. So we have y is equal to 81 minus 45 plus 4 is equal to 40. So if x is equal to -3, then y is equal to 40. So we have -3 and 40. Next, let's have x is equal to 0.5. So let's substitute 0.5. So we have y is equal to 0.5 raised to the fourth power minus 5 times 0.5 to the second power plus 4. And then 0.5 to the fourth power will be equal to 0.0625 minus 0.5 to the second power is 0.25, bring down negative 5 plus 4, and then simplify again. So y is equal to 0.0625, bring down, and then negative 5 times 0.25 is negative 1.25 plus 4. And then 0.0625 minus 1.25 plus 4 will be equal to 2.81. So if x is equal to 0.5, then the value of y is equal to 2.81. So next, let's have the next value of x, which is negative 0.5. Substitute negative 0.5. So we have negative 0.5 to the fourth power minus 5 times negative 0.5 to the second power plus 4. Then we will simplify. Negative 0.5 to the fourth power is equal to 0.0625. Then bring down negative 5. Negative 0.5 to the second power is 0.25 plus 4. And then bring down y equals, bring down 0.0625. Negative 5 times 0.25 is negative 1.25 plus 4. And then 0.625 minus 1.25 plus 4 is equal to 2.81. So if x is equal to negative 0.5, then the value of y is equal to 2.81. So we have 0.5 and 2.81. The next, let's have x is equal to 1.5 because it is in between 2 and 1. So let's have 1.5. So we will substitute. So we have y is equal to 1.5 to the fourth power minus 5 times the quantity of 1.5 to the second power plus 4. And then we will simplify. Y is equal to 1.5 to the fourth power is 5.0625 minus 5. Then 1.5 to the second power is 2.25 plus 4. And then bring down y is equal to 5.0625 and then negative 5 times 2.25 is equal to negative 11.25 plus 4. And then adding these numbers, we have y is equal to negative 2.19. So if the value of x is equal to 1.5, then the value of y is equal to negative 2.19. So we have 1.5 and negative 2.19. And then let's have negative 1.5 because it is in between negative 2 and negative 1. So we will substitute again. So we have negative 1.5 to the fourth power minus 5 times the quantity of negative 1.5 to the second power plus 4. Then we will simplify. So we have y is equal to 5.0625 minus 5 times 2.25 plus 4. And then bring down 5.0625 and the negative 5 times 2.25 is negative 11.25. Bring down 4. And then after that, we will add these numbers. So y will be equal to negative 2.19. So if x is equal to negative 1.5, then the value of y is equal to negative 2.19. So we have negative 1.5, negative 2.19. So after we have construct the table of values, we will now sketch the graph of the polynomial function using the table of values. So we have the Cartesian coordinate plane. So we will plot the points on our Cartesian coordinate plane. So we have 1, 0, negative 1, 0, 2, 0, and then negative 2, 0, which are located on our x-axis because these are the values of the x-intercepts. And then we have 0, 4 as the value of our y-intercept, which is located on our y-axis. And then we have 340, and then negative 340, and then negative 0.5, 2.81, and then we have 0.5 and then 2.81, and then next point is negative 1.5 and negative 2.19, and the last point is positive 1.5 and negative 2.19. So as we can see on our graph, the end behavior is located at quadrant 1 and quadrant 2. And then we have 1, 0, negative 1, 0, 2, 0, and negative 2, 0 has add multiplicity. So the graph will cross the x-axis. And then we have the number of turning points, which is equal to 3. And then after that, we will now sketch the graph of the polynomial function. So we will connect the points. So this is an x-intercept. So the multiplicity of negative 2, 0 has an add multiplicity. So therefore, it will cross the x-axis, going to the next point. And then after that, this one will bend, going upward, going to the next point, which has also an add multiplicity. So therefore, this will cross the x-axis going to the next point, and then going to our y-intercept, and then going downward, and then going to the next x-intercept, which is 1, 0, and it has an add multiplicity. Therefore, the graph will cross, going to the next point, and then going upward, and then going to the next x-intercept, which is equal to 2, 0, which has also an add multiplicity. This will cross the x-axis going upward. So this will be the sketch of the graph of the polynomial function. As you can see, we have 3 bends on our graph. So let's have our last example. Sketch the graph of y is equal to quantity x plus 1 to the second power times the quantity of x plus 3. So the first step is to solve for the x-intercepts. So since the polynomial function is already expressed in factored form, we can easily compute for the value of the x-intercepts. So we just need to equate x plus 1 by 0. So we have x plus 1 is equal to 0. So x will be equal to negative 1. And the x-intercept is point negative 1, 0. And then equate x plus 3 by 0. So we have x plus 3 equals 0. So we have x will be equal to negative 3. So we have the x-intercept point negative 3, 0. So the value of the x-intercepts are point negative 1, 0 and point negative 3, 0. After that, we will solve for the value of the y-intercepts. So in solving for the value of the y-intercepts, so we will just let x equal to 0. Y will be equal to quantity x plus 1 to the second power times x plus 3. So substitute the value of x, which is 0. So we have quantity 0 plus 1 to the second power times 0 plus 3. And then simplify. 0 plus 1 is 1. 1 times 1 is 1. Then 0 plus 3 is equal to 3. So the value of y is equal to 1 times 3, which is equal to 3. So if x is equal to 0, the value of y will be equal to 3. So we have the y-intercept 0.03. So after we have get the x and y intercepts of the polynomial function y is equal to quantity x plus 1 to the second power times x plus 3, the next step is to get the end behavior. So we will identify the value of the leading term. So we have x times x is x squared. X squared times x is x to the third power. So the leading term is x to the third power. So the value of the leading coefficient of the leading term is equal to 1, which is greater than 0. And the value of the exponent is to the third power, which is an odd number. Therefore, the end behavior is located at quadrant 1 and quadrant 3. And then after that, we will identify the number of turning points. So the number of turning points will be equal to n minus 1, which is n is the highest degree of polynomial. So we have third degree, so we have 3 minus 1 is equal to 2. So the number of turning points or the number of bends in the graph is equal to 2. And then after that, we will get the multiplicity of roots. So since quantity x plus 1 to the second power has even multiplicity, then the graph is tangent to the x-axis. And then since x plus 3 has add multiplicity, then the graph will cross the x-axis. So after we have compute for the value of x and y intercept, so the next step is to construct a table of values. So we will write the x and y intercept on our table of values. So we have negative 1, 0, negative 3, 0 as our x intercepts. and 0, 3 as our y-intercept. And then after that, let's try using x is equal to negative 2. Since negative 2 is in between negative 1 and negative 3. So we will substitute negative 2 in the equation y is equal to quantity x plus 1 to the second power times x plus 3. So it will be y is equal to quantity negative 2 plus 1 to the second power times quantity negative 2 plus 3. And then simplify, we have y is equal to negative 2 plus 1 is negative 1. Negative 1 to the second power is positive 1. Negative 2 plus 3 is positive 1, and then bring down 1. 1 times 1 will be equal to 1. So if x is equal to negative 2, then y is equal to 1. So we have point negative 2 and 1. And then after that, let's have x is equal to negative 4. Since the next number of negative 3 is negative 4. So let's substitute negative 4 on our equation. So we have y is equal to negative 4 plus 1 to the second power times the quantity of negative 4 plus 3. And then we have negative 4 plus 1 is equal to negative 3 to the second power. And then negative 4 plus 3 is negative 1. And then simplify, negative 3 to the second power is positive 9. And then 9 times negative 1 is negative 9. So if x is equal to negative 4, then y is equal to negative 9. So we have point negative 4, 9. And then after that, let's have x is equal to 1 since the number next to 0 is equal to 1. So let's substitute. So we have y is equal to quantity 1 plus 1 to the second power times 1 plus 3. Simplify. So we have 1 plus 1 is 2 to the second power times 4. And then 2 to the second power is 4 times 4 is equal to 16. So if x is equal to 1 and then y is equal to 16. So we have 0.116. So let's now sketch the graph of the polynomial function. So let's plot the points on the Cartesian coordinate plane. So we have negative 1, 0. And then we have negative 3, 0 as our x-intercept located at the x-axis. And we have 0, 3, which is our y-intercept located at the y-axis. And then we have negative 2, 1. And then we have negative 4, 9. And the last point is 1, 16. So the end behavior is located at quadrant 1 and quadrant 3. And then after that, quantity x plus 1 to the second power has an even multiplicity. And then x plus 3 has an odd multiplicity. And then we have number of turning points or number of bends, which is equal to 2. So let's now sketch the graph. So let's start from here. Going upward, up to the next x-intercept, which is negative 3, 0. And negative 3, 0 has a roots of negative 3 and its factor is x plus 3, which has an odd multiplicity. So if it has an odd multiplicity, it will cross the graph up to the next point and then going to the next x-intercept, which is negative 1, 0, which has an even multiplicity. So if it has an even multiplicity, then it is tangent on the x-axis. So this one will bend on the x-axis because it is tangent. Then after that, going to the next point, so this will be the sketch of the graph of our polynomial function. And as you can see, we have two bends. So the first bend, and then this one will be the second bend.